Okay, so now that we know a little bit more about matrices, today we're going to talk about how to multiply matrices. And this is a little bit trickier. All right, so our goals here today are to be able to multiply matrices, and that's pretty much it. All right, take a look at this picture. The answer is correct, but how? We'll pause here. Okay, so how do we multiply matrices? First, I want to just review the commutative property. So you guys know that if I take and multiply 5 times 2, we get 10. And if I flip that around, you know that you still get 10. Okay, 2 times 5 is 10. This is the commutative property. Now, one thing that's very, very important to know is that with matrices, the commutative property does not apply. It is not like regular multiplication. So if I have two matrices, A and B, they will not always be the same if I flip these around. Okay, that's really important. So while commutative property applies in regular multiplication, it does not necessarily apply in matrix multiplication. So that's a really important note. All right, so how does this work? So a couple things we want to go over first. Matrix multiplication, you are going to, if you're multiplying two matrices, let's say A and B, they can be multiplied if and only if the number of columns in A equals the number of rows in B. What the heck does that mean? Well, for example, if we have an M by N matrix and we're multiplying it by an N by P matrix, the answer would be an M by P matrix. And that probably still doesn't make a whole lot of sense. So let's look at an example here of these first two matrices. So we have this matrix here. What you want to do to determine if you can multiply is you want to write the dimensions of this. So this is a 4 by 3 matrix, right? 4 rows, 3 columns. And this matrix right here is a 3 by 1 matrix. In order to multiply these two inner dimensions need to be the same. Okay, so that has to happen. So this is not like addition or subtraction where they have to have the exact same dimensions. That is not the case. Here, they just need these inner dimensions to be the same. And then the second piece is these two outside dimensions, 4 and 1, these are the dimensions of your answer matrix. Okay, so that means my answer would be a 4 by 1 matrix, okay? And then that's how I would go through, and we'll talk about how the multiplication works here in a second. But this is the first thing you need to determine if you can even multiply them first. So it's really important you put them in order. Notice if I flip these around and tried to multiply the 8, 7, negative 1 matrix by the other matrix. In other words, if I put this in front, now I would not be able to multiply them because it would be a 3 by 1 times, it would be a 3 by 1 times a 4 by 3. And notice these inner dimensions are not the same. So that's why it's really important to write your dimensions out and make sure your matrices are in order. Again, not commutative necessarily there. All right, so let's look again at, let's try another one here. Dimensions of this matrix here are a 4 by 3. And this matrix here would be a 2 by 4. So you want to look at these, are these two the same? No. So I cannot multiply these two matrices. This would be impossible. Okay, can't do it. No go. All right, so now let's look at another one here. This last one. So this is a 5 by 2. And we're going to multiply that by a 2 by 4 matrix. Again, these are the same, so we're good. Okay, and my answer matrix then here would be a 5 by 4 matrix that I would make for my answer. Okay, so that's the first thing you have to do to determine if you can multiply. All right, now let's actually try this out a little bit. So matrix multiplication is kind of weird. It's going to take some getting used to. So first thing we're going to do, though, is we're going to zoom in on this and write out our dimensions. So this one is a 2 by 3 matrix, and this one is a 3 by 2 matrix. The inner dimensions are the same, so we're okay. That works out. And then my answer is going to be a 2 by 2 matrix. Okay, so what I'm going to do is I'm actually going to make a 2 by 2 matrix. I know this has to be a 2 by 2. And that means I have 4 numbers I'm going to need in here. These 4 slots, okay? So how do we get those numbers? That's the next thing that we're going to learn. I'm going to erase this here. So now that we know that we can multiply, how does this work? Well, this is going to go back a little bit to what we talked about with our addresses. So this right here is in the position 1, 1. So I'm going to call this answer spot 1, 1, meaning row 1, column 1. So what that actually does is these two numbers also tell you what you're going to multiply. So row 1 of the first matrix is this. You're going to multiply that by this column right here. Okay? So, and then, so you're going to go 1 times 2. Okay? So again, 1 times 2, that's where that came from. And then you're going to add the next two numbers. So negative 2 times negative 1. So negative 2 times negative 1. Okay. And then you're going to do 0 times 4. So notice I'm just going this times this. All right. So 0 times, so plus 0 times 4. Okay, so now, you can do this in your head, but I'm going to write it out for this time. Okay, so this would give me 4. So that goes in this position right here. That's 4. All right. Okay, so now let's do, I'm going to do this spot right here. So that is row 1, column 2. Okay, so that means I'm going to go row 1 now times column 2. And so what does that mean? So we're going to take 1 times negative 8 plus negative 2 times 4 plus 0 times 7. Okay, so that would be negative 8 plus negative 8 plus 0, which is negative 16. And that number goes in the 1, 2 spot. So this would be negative 16. All right. Hopefully that's making a little bit of sense to you. All right, now we'll switch colors again. We're going to do the answer. This is row 2, column 1. Okay, so now we're looking at row 2 times column 1. So that means I'm going to go 3 times 2, then 6 times negative 1, then 5 times 4. So I'm going to write it out. 3 times 2 plus, notice I'm adding these when I multiply those entries, and then I add the numbers up in between. So 6 times negative 1 plus 5 times 4. Okay, that's 6 plus negative 6 plus 20. Okay, that would be 20. So that goes right here. All right, and then we got one more entry to fill out. So let's do that one. And this is row 2, column 2, so I'm going to go this times this now. So 3 times negative 8 plus 6 times 4 plus 5 times 7. Okay, so this gives me negative 24 plus 24 plus 35. And that's 35. All right, and that goes in that address as well. So 35. So my answer is 4, negative 16, 20, 35. And there we go. You've just done matrix multiplication. Hopefully that makes sense. See you later.